So, ladies and gentlemen, let's take a gander at our new topic for today. It sounds funky. It's literal equations and formulas. So you might think, literal equations, oh my word, that sounds complicated. So our goal is to rewrite and to use something called literal equations, and we're going to solve problems. Before we do that, let us discuss and talk to your neighbor about what two steps did you use to solve A. Then I want you to do exactly the same idea over here with B and C. Don't be afraid of the new letters that are there. Treat those letters the same as you would the numbers over here. So with your neighbor, go ahead and discuss real quick the steps. Go. So as you discussed, the two things to do on this are simply to subtract by 7, then divide by 4, which quickly yields us this. And it's okay if it's a decimal or a fraction as our result here. So we get 4x equals 15. Then when we divide by 4, and some of us panic and say, 15 can't be divided by 4. And the answer is, actually, it can be. We just don't need to write anything more. So here's the nice thing. 15 over 4, and we're done. Oh, but can I just punch that into a calculator? You can. But most of the time, especially on standardized tests, when you address them, they're going to leave it like this because oftentimes they don't want you to pull out your calculator to try to figure out what it is, just to keep it simple. So we like to, as mathematicians, generally leave things in this form right here, 15 over 4. Now, if it were a word problem, how far away does somebody live? You wouldn't leave it as this. You would say, you would do the division, which would be 3 miles, 3.75 miles, or 3 3/4 miles. So that would, when it's a practical situation, we could bring it into decimal world. But for now, that's good. All right. Now as we look at B, notice that there's a difference with B. Instead of adding something there, adding, for example, 7, here I'm adding B. And I still need to move that around. So what are the steps we need to do on this one? I'm going to subtract the B. So let me write it exactly as I say it. Subtract B. Subtract B. And 22 minus B can't be simplified. Why? Because they're not like terms. So when they can't be simplified, you write them as you see it. So don't stop and say, we can't do anything. I can't write anything. You can. It's just you can't simplify it into a single term. Now we just say 22 minus B. Let's now divide by 4. Whatever I do to one side, I do to the other side. So we do that. X equals, now what's over here on the right side, nothing simplifies very easily. Now I can split it into 2 fractions, but I don't need to. For our purposes, we're going to leave it like this. Since nothing simplifies, then you don't have to do anything. So when you have a letter which seems like it's complicating things, and the answer doesn't look pretty, like a 6 or a 5 or whatever, it actually is less complicated. Why? Because I don't have to simplify here. I don't have to simplify here. I just leave it. I'm done. Now let's look at C. All right. Like we saw earlier, I do have to subtract 7 on both sides, but then also I have to get rid of that A in just a moment. So now I bring down the A times X equals 15. This is exactly like we did with part A. And now, instead of dividing by 4, I divide by A. Oh, but Swenson, we can't divide by A. Yes, we can. We just don't know what it is. We are allowed to divide by A, as long as A is not 0, in fact, which it probably isn't. But if A were 0, we would get an impossible situation. So I could say here, the answer is X equals 15 over A. And we should probably make a qualification there. A can't be 0. It can be any other number on the real number line, but it can't be 0. So there we go. Notice that no matter the situation, whether we're dealing with numbers or letters, we treat them the same. I can subtract letters like here. I can divide letters like here. Or I can subtract and divide by numbers. All works out. Sometimes it's cleaner. For example, this, it's a single number. And this one is more complicated looking, but actually technically less. We didn't have to simplify anything. So, by way of introduction here, Our friend Hafiz McGillicuddy III, he unwrapped the perimeter. So here's the perimeter of a rectangle. Here's the perimeter, and all he did was unwrap it. So here's L, W, L, W, L, W, L, W. And then he just stretched it out. In other words, so that he could measure how far around this was. Then he drew the segment underneath. Write an equation for the segment that he drew. So what's an equation down here? And then how else can you arrange the segments to form a different equation? So with your partner, go ahead and have a quick conversation and also do it. How do I write this as an equation? And if you want, let's use perimeter, P equals whatever it is. What's that equation? And there's a couple different ways to write it. In fact, feel free to move these, move the blue and the orange around just by redrawing the situation. So go ahead and with your partner, have a quick conversation. So one way to say it is more of along the lines of thinking globally. And so one way to write this is we have L times 2, or 2L, and then we have two W's, and we add them together. If you wanted to be more straightforward, maybe your little brother, they might have said something like this, where if we just look at the diagram, we have an L plus a W plus an L plus a W. So that's another way to have written it. L plus W plus L plus W. Just so that for clarification, I draw my L's like this with like cursive, just like they did over here, because oftentimes in a book, it's going to be italicized. That means it's written to the side, slanted a little bit. All right, and besides that, we could have flipped things around. You could have said this: I have 2W plus 2L. You could have also, like we said, moved things around, put the W's next to each other. W, W, W plus L plus L. So all of these are equivalent, essentially, because we're taking the same segments and all we're doing is rearranging them, but their length the total length never changes. So today what we're going to look at is something called literal equations and also some formulas. Now you already know what a literal equation is, you just don't know you know it, okay? A literal equation has to do with literature, right? Literature equation. So this is what a literal equation is. An equation, so I'm going to use EQ for equation, whose letters stand for words. Okay? For example, we have an interest equation. And this interest equation, and this is called simple interest, so you might want to write the word even in the front, simple interest, as opposed to something called complex interest, but simple interest. And each of these letters means something. I stands for interest earned. Interest earned. P, and sometimes the P is actually uppercase. So for our purposes, we'll keep it low, like our book. But I've seen the principal being capitalized. Principal amount. If you want to know what principal means, you're like, I don't quite get that. That's the original. That's what it means. So for example, if I put $1,000 into my savings account, $1,000 is my principal. Okay, next we have R, which stands for, and we'll be specific, it stands for rate, and usually we mean the annual rate. It could change, but context usually is the annual rate. And we'll unpack that in just a few minutes. Lastly, T generally means, in math and science, T means time, or how long something occurs. So let's now take this simple interest idea, and we'll go down to example number 1. If you want to calculate the amount of time it takes to earn a certain amount of interest, So you want to know, when will I earn $50 or $30 or something like that on your investment with simple interest? What equation can you use? So let us start with the literal equation for interest. Interest equals principal times rate times time. And let's review again the question. If I want to calculate the amount of time, so I want to figure out how long it will take to earn something. How many years or months, depending on the unit being used. So I need to get t time by itself. So it looks like, and so we're going to say, just so that we are clarifying what's going on, we need to solve for t. So please write that down if you haven't already. Solve for t. That is a way that we say to get t by itself. It does not mean actually give myself an answer. It doesn't necessarily mean what's the value of t. Solve for t means to get t by itself. Another way of saying it is to isolate t. And you can see the word solo in these, right? Isol, S-O-L, sol, solve right there. Same root, which means solo, which means alone. Get t alone. Okay, so when we have I equals P, R, T, if I want to get t by itself, I need to undo the operations that are happening. If we recall, when the letters are next to them, each other there, it means multiplication. So it's P times R times T. So to undo the multiplication, I have to divide. And notice what I'm dividing by. I need t by itself, so I'm going to divide by those two letters there. So, dividing by the P and the R. You don't need to write that times there, but it might be helpful. So whatever I do to one side, I do to the other. So, divide by P times R. Notice on the right side, the P's reduced to 1, the R's reduced to 1. So, what's really the only step that I've done here? I divided by PR. And now to finish up, as we saw earlier, some things can simplify. The P divided by P is 1, R divided by R is 1. So on the right side, everything reduces to simply T. But on the left side, there are nothing here that we know of can reduce because we don't know what those numbers are. We just know that they are letters. So we leave it as we see it. It sounds more complicated, but it's actually less. Why? Because I don't actually have to write a new number. I don't have to combine these two to get 5 or something like that. I just write exactly what I see. And so there's my answer. I have solved for t. T is by itself. And now, if I know the interest, principal, and rate, and I want to know how long it's going to take, I just plug it into this new formula. And there we go. Now it's your turn. Go ahead and practice. What equation would you use to calculate the principal amount? So, for example, you know the other three. You know the interest, you know the rate, and you know the time. But how much money do you need to invest is the question over here. So take a moment to do that. One more formula that we want to look at is called the Celsius or temperature conversions. In Europe, they use Celsius, and here in the United States, we use Fahrenheit. So that's what each one of these mean. C stands for Celsius, or the temperature in Celsius, and F stands for Fahrenheit. Fahrenheit is spelled sort of funny. I think it's originally a German word. In a half an hour, Sarah is meeting her friends at the lake, which is 6 miles from her house. At what speed must she ride her bike to get there on time? So we're assuming she maybe has a speedometer on her bike, or she has an iPhone app with GPS that shows her speed. Okay, so remember our formula starts off like this. D equals RT. But we're asked to find what speed? In other words, how fast is she going? We're finding rate. So if I want to get rate by itself, I need to divide both sides by t. So now I have rate is equal to d over t. So what did I do in step 1? Solve for rate. Remember, solve for means to get it by itself. Isolate the rate. Because this creates a formula for rate. Now, the second thing we're going to do, number 2, is we want to substitute values in. So, we are told 6 miles here. We're told 6 miles. That's a distance. And in a half hour. In a half hour. So now we just need to substitute those values in. Rate is equal to 6 miles divided by half an hour. Notice, let's put half an hour, or 0.5 hours. When I do this division, R is 12. Notice the units are built in right here. Miles on top, hours on the bottom, miles per hour. So 12, and now we write usually MPH for miles per hour. So how fast must she bike? 12 miles per hour. On part A, all we simply need to do to get M by itself is to subtract N from both sides. Don't be afraid. We just write what we see. They don't combine any further, but M equals P minus N. Well done on that one. Now, over on part B, what we need to do is subtract N from both sides, as we see here. And then we write what we see. M equals P over N. Done. Part C, we have more to get rid of. More to get rid of. I need to get rid of both the N and the G. Whatever I do to one side, I do to the other. So M by itself is equal to T over NG. These are not literal equations because they don't mean anything. I just threw some letters down just to get you to practice that. Lastly, this one requires a little bit more thought because we have to subtract the T first, as done there. And then we bring down the PM equals Y minus T. Now we have to divide both sides by the letter P. So we do end up with something sort of funny looking, Y minus T all over the letter P. All right, it is time for us to look at example number 4. If the perimeter of a small barn is 144 feet and the length is 40 feet, how can the width be determined? We do have to make an assumption. They didn't tell us about the barn, but it's probably fairly safe to assume that the barn is what shape? Probably a rectangle. Even if it were a square, you could say a square is a rectangle. So I'm going to use the perimeter formula, 2L plus 2W. We are asked to find the width. So I need to get W by itself. So I'm going to subtract 2L from both sides. Don't worry, because P minus 2L doesn't reduce any further. It equals the 2W. Now what we need to do is get rid of that 2 by dividing both sides by 2. So here's our super secret formula. I'll use what's called the symmetric property to move the W to the left side. I just like it better that way. Perimeter minus twice the length divided by 2. Now that we have the formula, we can now take what we know. We know that the perimeter is 144 feet, so I'm going to place that in, substitute into P. I also know that the length is 40 feet, so I'm going to substitute that into L. So let's go ahead and do that. 144 feet goes here, minus twice the L, which is 40 feet. And whatever we get, we're going to divide that by 2. show that. Up here, I get 64. Divide by 2 to get 32. So I'm claiming that the width is 32 feet. So how do I check that? So the check is just simply to say this. 40 plus 32 plus 40 plus 32. And when you check that, it does indeed sum to 144. Your turn. In this triangle, we know the area and the base, but your job is to first isolate the h, get the h by itself. In other words, find a formula to find h. Then I want you to substitute. So in this one, we have the area of a triangle, 1/2 base times height. And if I want to get the h by itself, notice the two things I need to get rid of. I need to get rid of the half and the b. So how do I get rid of the fraction? If you multiply both sides by 2, the fraction goes away. So I'm left with twice the area is equal base times height. Now we're going to divide both sides by b over here and here. So twice the area divided by b gives you the height. There you go. Now let's plug things in. H equals 2 times 18 divided by 9. All that goes into your handy-dandy calculator, or you can start reducing here. And we end up getting that h is equal to 4 inches. So here we're visiting Budapest. By the way, Buda and Pest, they're two cities. They're on either side of the river. Hungary, and we're told that it was going to be 40 degrees Celsius today. Should I wear a jacket? So let's go back to our super secret formula where we said this. Celsius is equal to 5/9 of Fahrenheit minus 32. So this one here, if I want to get F by itself. So let's walk through the process here. I'm going to get Fahrenheit by itself because I want to know what it's like in my universe here. So I multiply both sides by the reciprocal, 9/5. Then I need to isolate the F by adding 32 to both sides. So here's my formula. Take the Celsius, multiply by 9/5, and then add 32 degrees to that. So when I do that, it's going to be 104 degrees in my scale.